So today we're going to jump into another extension of proportions. This whole chapter really is just talking about different ways that we use proportions, and it's just really exciting to see all of the different ways that they show up in real life. So today the application that we're going to talk through is about scale drawings. And so you see a picture here of a map of the state of Pennsylvania. And we call this a scale drawing because this clearly is not how big Pennsylvania is. Pennsylvania does not fit on my smartboard or on my computer. So this is a picture. It's an application of proportions because it is a proportional size to the actual state, but it uses a scale, and you see that scale up here in the corner. All maps have these, and hopefully you've seen them or experienced them in social studies class, but it shows us that this length from here to here, which is about an inch long, is equivalent to 50 miles. So if we started measuring around, we could figure out how far York is from Pittsburgh, for instance, by measuring that distance and then converting it into miles using this scale. Another way or place that we see scale drawings often is in blueprints, and this is something that if you one day become an architect or jump into other art-related jobs, architects and construction workers have to use blueprints. They have to take something that they're building, either a house in this case or a statue or another building, and put it onto a scale size of it so they can figure out what supplies they need and all sorts of things. So we see blueprints. And then maybe a way that you've seen them as well is just scale figures. We see maybe as a kid you played with Hot Wheels or toy action figures that you see here. All of these are scaled because they are in a sense proportional. You notice that even in these action figures here, the bodies are proportional to real life. They don't have massive heads and then tiny stubby feet. It's still a proportional body. And so today we're going to talk about, and we have some notes that are going to walk us through some key vocabulary when it comes to scales so that you can understand what kind of questions you're asking and what sort of applications we can dive into. So the notes in front of you look similar to the notes I have here on my screen, and you see here two different cars. And if you look at the information that they give us, they tell us that the length of this car over here is 14 inches, and the length of the car over here is 20 feet. And so besides the fact that these two cars look almost identical, these two cars really have a scale relationship, and you see that down here. The smaller car is a scale model of that larger car. And so we're going to talk about some vocabulary. You don't need to write anything in these boxes or in response to this question, but we're going to talk about some vocabulary as to how we write scales and how we can use scales to find missing pieces. So down at the bottom we have a couple definitions that I need you to write down. And the first one is what a scale drawing is. And we just talked about this, and you can write as I read this out loud. But a scale drawing is an enlarged or a reduced 2D drawing of an actual object. And we get those enlarged or reduced drawings by what we call a scale factor. And that's a word that you see down. We're going to define that as well. But this is what a scale drawing is, and these words enlarged or reduced tell us that it's getting bigger or it's getting smaller. So a 2D drawing could be bigger than the real life thing, or it could be smaller than the real life thing. Then we have a scale model, which is really the same thing as a scale drawing, but this is the 3D version. So it's the action figure, or it's the car, or it's the doll. It's something that's three-dimensional as opposed to a flat piece of paper, which is what we would call two-dimensional. So that's the only difference between a scale drawing and a scale model. But what I'm about to say next, and this is what a scale is, this is the most important thing. So this is where I really need you to tune in to the conversation, because at the end of the class period, this is what you're going to need to have walked away with from this video. When we write a scale, we always write it in the same exact way. And we always write it, I even have it boxed here for you. We write it as a ratio because, again, we're really just talking about ratios and proportions here. We write it as a ratio, and we write it in this specific way, comparing the model length to the actual length. I'm even going to highlight that here for you because every single time you see a scale, this is how it's given to you. It's given the model size, so the toy car to the real life car, or the model distance on the map to the real life in miles distance. And this word corresponding here is just talking about two things that are the same, in the same place. So I'm even going to go back to my map here just to show you what that means. But it's talking about this model distance, so the inch, to the real life. So this inch distance from York to Pittsburgh, to how many miles is it actually? But corresponding is just talking about that same distance. So on your notes, I used the example from the car just on top of the page. I just wrote the scale for it. It's 14 inches to 20 feet. What you see up here at the top is just the exact same measurements that they gave you. That's the scale. 14 inches in the toy car represents 20 feet in the real life car. And then lastly, the big difference we need to talk about is we have scales, and then we have what we call scale factors. And scale factors are just the unit rate. I put it in terms that you hopefully know. It's the unit rate version of scale. And we're going to write an example here together just so that we are all on the same page. And I'm actually going to use the example we used for our scale. So if you have 14 inches to 20 feet, which is the scale of the car on top of the page, the scale factor is going to be the unit rate version, unit being 1. So we want those inches on top to be in terms of 1 inch. What does 1 inch represent in feet? And of course, this is a proportion that you guys know how to solve at this point. We're going to take 20 times 1, which is 20, and divide it by that 14. And I believe if you type that into your calculator, you get a really long decimal. I think it comes out to be the fraction form of 1 3/7 feet. And now that we have this scale factor, any inch amount, say we have 17 inches, we could multiply by the 1 3/7 feet to get what the actual version would be. So that's what a scale factor is. It's asking for the unit rate version. If you flip these notes over, you'll see a page on the back that looks like this, and I'm just going to walk you through how you go about calculating, if you're asked a question, calculating the scale factor and calculating a length or a distance from a drawing. So the first thing that you need to do if you are calculating the scale factor is we need to write a scale as a fraction or a ratio. Just in the fraction form, and I said again, there's a very specific way you have to write it, and this again, you just need to know that a fraction scale is comparing the model length to the actual length, model to actual. Step number 2, you probably won't ever really have to do. It's just saying that you should change the lengths to the same unit of measure. I'm not going to ask you to do that step, but in case you're asked that, you'll just change or have to convert inches to miles or something like that. And then lastly, simplifying, and again, that's to the unit rate version. You want to get that 1 on top. But then we'll also run into scenarios where they're not asking for the scale factor, they're asking you to find a length or a distance. And in order for us to do that, they'll always give you a scale in order to find that distance. So you're going to use the scale that they give you and the given length that they give you, and then we're going to set up a proportion. And that's where this really comes down to, can you match up units and set up proportions like we've been doing all month now. This is just yet another application of that and where we see it in real life. So I have a couple that I want to walk through with you. There's a couple here at the bottom that you see. Just make sure that we're all on the same page, and then you'll have a couple to try on your own. So here's our first example. On a map, there's two cities that are 3.25 inches apart. The scale on the map is 1 inch to 35 miles. I'm going to highlight that. That's our big ticket there. What's the actual distance between these two cities? So you see the directions over here tell us to use the scale and the given distance to set up our proportion. So we know we need this template here to get ourselves set up. The first thing I would always write down is the scale that they give you. They gave me 1 inch to 35 miles. And they gave us, again, one more piece of information. They either are going to give you the inches, the model, or they're going to give you the real life version. And in this case, they gave you the inches. So we're going to match that up with the inches on top, which means we're trying to find that bottom number. At this point, you can cross multiply and solve. I'll let you go ahead and do that, and we'll check, make sure we get the same answer. I got that x equals 113.75 miles, and that would be our final answer if they were 3.25 inches apart on the map. In real life, they're 113 miles apart. So let's try it again with example number 2. This time the scale drawing has a scale of 1 inch to 1.6 feet. If the kitchen is 10.5 inches long, on the drawing, what's the actual length? So again, we need to set up our proportion. We'll use our template that we've been using. And first we're going to just write in that scale they gave us. They told us that 1 inch is being compared to 1.6 feet. The other piece of information they gave us was inches, so 10.5 inches on top with an X on the bottom. And again, you can go ahead and cross multiply to see what you get. You got 1.6 times 10.5, then divide it by 1, you'll get 16.8 feet. In real life, that kitchen will be 16.8 feet. Then lastly, these final two questions aren't asking us to find a distance, they're asking us to actually find the scale factor. So they tell us that the scale model of a car has a scale of 2 inches to 5 feet. And I'm going to start off and just write that out. They told us 2 inches to 5 feet. And they want to know what that scale factor is. What's that number that we can multiply all the inches by and convert to feet? So again, we said that that's the unit rate version, which we always want a 1 on top with. And you can cross multiply and solve that, or if you can just simplify, you realize that we're jumping from 2 to 1. What is that missing measurement? And I got 2.5 feet down below. So that's our scale factor. 2.5 feet, 1 inch represents 2.5 feet. And then lastly, a map has a scale of 2 feet to 4 miles. What's the scale factor? So I'm going to write in that initial scale. And then again, I'm trying to find that unit rate version. What's the scale factor? Well, for every 1 foot, I'm just going to take my miles, divide them by my feet. I'm going to get 2 miles. So that again is my scale factor that I could use to help me solve any problem. So with that, I just want you to kind of practice some of these. I'm hoping that really your application of proportions, you'll continue just matching up your units. But if you can come show me your notes, show me that you have worked through both sides of this page, I'm going to give you a paper that looks like this. There's just a couple questions on here as well, and I'm going to warn you that question number 4 is the tricky one. Read that one carefully, but the rest of them are very similar to the questions that we just went over together. So come check in with me, show me the notes, and I'll give you your practice page.